As we begin to prepare to work with trig identities, it's important for us to recall some information from algebra and how operations in algebra can be extended into operations in trigonometry. So to start with, we're just going to look at how did we multiply out expressions, how did we combine expressions if we were adding or subtracting and we didn't have a common denominator, just so that we remember and actually practice looking at these problems in a way that is consistent with what the operations mean. So first of all, we're going to perform the indicated operation and simplify. So whatever it wants us to do, whether it's to square a quantity or multiply it out or to add two things or whatever, we want to go ahead and do that operation and simplify as possible. Now, just kind of as a disclaimer here, this segment is done prior to learning about trig identities. So there might be some things here that actually later on, once we have the 8 fundamental trig identities, we would be able to simplify a little bit further, but expressions instead of going on to the trig identity substitutions. So our first one says to perform the operation where I take 2 times the sine of t minus 1 and quantity square it. So you want to think, well, what do I have inside the parentheses that is being squared? Well, I have 2 different terms in the parentheses that's being squared. Remember, terms are separated by plus or minus. And if I had more than one term in a parenthesis that's being squared, remember, I have to multiply all of the terms of one grouping times the terms of the other grouping. So I want to actually write this out as 2 sine t minus 1 times itself, because that's what squaring something means. Now, if I'm going to multiply this out, because it's a 2-term expression times a 2-term expression, I have to do the extended distributive property, which a lot of times we call the acronym FOIL. So first term times first term, 2 sine t times 2 sine t is 2 times 2 is 4, sine t times sine t is sine squared t. So this will give me 4 sine squared t. And just remember that really it's 4 times sine of t squared, but instead of putting the parentheses in there, the way that we do that is to just tuck the square between the trig function name and the angle to say that it means that the entire sine of t is squared. So that gives me in my firsts. Now my outer, 2 sine t times negative 1 is a negative 2 sine t. Inner, negative 1 times 2 sine t is a negative 2 sine t. And last, negative 1 times negative 1 is positive 1. So when I look at these 4 terms, I want to combine any like terms. Remember, like terms are terms that have the same variable with the same exponent on the variable. So in trig functions, it has to be exactly the same trig function with the exact same exponent on the trig function. So 4 sine squared t doesn't have a like term with it. But when I have minus 2 sine t minus 2 more sine t, that's minus 4 sine t. And then my plus 1. So that's what we have in terms of the simplification of multiplying that out. Let's look at the next one. So here it's 3 cosine t plus 1 times 2 cosine t minus 4. So 2-term expression times a 2-term expression. Again, we're going to multiply it out using FOIL. So 3 cosine t multiplied to 2 cosine t is 6 cosine squared t. Then outers, 3 cosine t times negative 4 is negative 12 cosine t. Inners, 1 times 2 cosine t is plus 2 cosine t. And last, positive 1 times negative 4 is negative 4. So then when I look, there's no like terms with 6 cosine squared t, but I have minus 12 cosine t plus 2 cosine t. So combined, that's a negative 10 cosine t. So I have 6 cosine squared t minus 10 cosine t minus 4. Okay, how about if we're adding when we have fractions but their denominators don't match? So remember, if you're adding fractions, you have to have common denominators. And if you don't have common denominators in the original expression, you have to build to get common denominators. So I have a denominator of 1 minus sine t, and I have a denominator of cosine t. They're not the same. My lowest common denominator is going to be the product of 1 minus sine t times the cosine t. So my first fraction needs to be built with a factor of the cosine t to get a common denominator, plus, and my second fraction has the cosine t, it needs to be built with the 1 minus sine t. Now, once we built to get the common denominator, we're going to remove the parentheses and combine like terms across the numerator, but keep the common denominator. So my common denominator is the 1 minus sine t times the cosine t. And then in the numerator, cosine t times cosine t is cosine squared t plus, and then this is 2 terms times 2 terms. So we're going to have to do like what we did in our earlier multiplication. So that'll give me a 1. And then minus sine t minus another sine t is minus 2 sine t. And then the negative sine t times negative sine t. Negative times negative is a positive. Sine t times sine t is sine squared t. Now here's a case in point where what I mentioned before about we're not taking it that extra step yet because we haven't gone into the 8 fundamental trig identities. If you're in a course that has done the 8 fundamental trig identities already, you'll notice that cosine squared t plus sine squared t is a particular value whose replacement is simpler. And once you take out the cosine squared t plus the sine squared t and put in what it's equivalent to, you'll be able to simplify a little bit more in that expression. The next one is a fraction, again, where we want to add these, but currently they don't have a common denominator. Well, the lowest common denominator between sine t and cosine t is sine t times cosine t. So my first fraction already has the sine t. It needs to be built by the cosine t. And the second fraction already has the cosine t. It needs to be built by the sine t. When I add them, I keep the common denominator and I add across the numerator. So 1 cosine t is cosine t plus 1 sine t. That's just cosine t plus sine t, combined in its fraction form. So those are some expressions that we just wanted to apply the algebra idea of how to multiply them out, how to build to get common denominators to add together fractions. And we'll revisit this other one later on when we get a little bit more of the trig identities under our belt.